Hey guys, welcome back to another video. Today I'm gonna show you my ALU I just made. My 4-bit ALU, and it can add, subtract, and compare. And it was made in CircuitVerse. I just created my account on my desktop computer. So this is supposed to be a binary one. So let me zoom in. Okay. So we can zoom in. And these are the inputs, which also is it can so we have input. It's a bit hard. We have input A and input B, and also carry and or borrow. So, and we also have an add subtract operation input. So when I switch this on, it will turn to subtraction, and when I switch this off, it will be addition. Let's first go to addition, and we could add some numbers, and you could understand if you know binary, but so let's try 3 plus 6. So this thing will calculate itself. 3 plus 6 equals 8 plus 1, and 8 plus 1 equals 9. So the answer is 9, which is correct. So I guess we could try another number. And do you know what happens that if I want to choose 8 plus 8, it will go back, and then the answer will be 0 because now our ALU got overflowed. So this overflow bit will turn on. Okay, and these are the 6 flags in there, and these are the 4 output bits. So let's go switch back to subtraction. And I also forgot, there's also a carry bit as well, and when you turn it on, then it will be just 1 plus overflow. Let's just say that it's going to be overflow is going to be 16. So 1 plus 16 equals 17. So this is correct. Like 8 plus 8 plus 1. So 8 plus 8 is 16, and then 16 plus 1 is 17. Okay. Let me turn off all the bits here. And let's go turn on the operation to subtract signal. So all it does is that it will switch to the full subtractor signal. So it goes to all these AND gates will be turned on, and all these AND gates will turn off, and all these. So let's try to do something. Like let's try to so 3 minus 1. 3 minus 1. Let's see if it can calculate. So 3 minus 1 equals 2. So the answer is correct. Yeah, I think our ALU is working, which is pretty good. And also, if I want to make a negative number, like let's say like 1 minus 2. So 1 minus 2 equals negative 1. And you see all these bits will be on, and we'll be having negative bit. So let's just say this one is negative 16, and so when all these bits are on, will be 15. So 15 plus minus 16 equals negative 1. I mean, like 15 plus negative 16 equals negative 1. So you could also make negative binary numbers as well. And you can also turn on the borrow signal. So borrow signal, that is 1 minus 2 minus 1. So then now it will be, so 2 plus 4 equals 6, and then 2, and then 8. So 14 plus negative 16 equals negative 2. And we could also do this as well, like this. Now I forgot. Now let's also compare these numbers. So let's try. So we have 3 more flags remaining. I don't know how long I have recorded, 4 minutes. We have 3 more flags. These is A is greater flag, and A is equal, and A is less flag. So let's try something. So let's go compare like 3 and 6. So 3 and 6, let's compare. So 6 is greater, and let's check our ALU. So B is 6, and as you can see, B is greater, so this is right. And how about something else? Let's try to set these bits to equal. So like 6 compared to 6 will be equal because they're both the same numbers. And as you can see, it will show the equal flag there. And finally, let's also try compare 7 and 6. So 7 is greater than 6. So that means A is greater, and this is correct. All these compare instructions are going to this full subtractor circuit. Okay, the full subtractor circuit could also compare numbers as well. I just figured out an idea from somewhere from my mind. And I could also show you these ICs as well, which this is the full adder, which looks something like this, and this is the full subtractor, which is like this. So this is borrow out, borrow in. There's also the CPU part, but I didn't use that. So this is the end of this video. Bye. Can't I stop recording?